Thanks for joining us for the interview portion of the Data Speaks competition, created in partnership with RFG 2018 and Sequent. I'm Nicole Doucette, a science communication specialist with Sequent, and I'm joined today by Lavie.
Hi.
Hello, from the University of Saskatchewan.
Yes, I am.
Welcome.
Hi.
Okay, so your original abstract title was Semi-Automatic Identification of Unconformities for GIS Geological Maps.
Yes.
What is your revised non-specialist abstract title?
Well, funny enough, there's no revision for the abstract title, and that is the whole point because, first of all, there's not many technical work in the original abstract. I would say GIS geological map is the common concept for lots of people. I think the only really technical work in there in terms of geology will be unconformities, and that's why we think that it needs to come across to the audience. So there's no revision for the original titles.
Okay, great.
Yeah.
And so what question are you trying to answer?
Well, the question that I'm trying to answer is to identify unconformities from a GIS geological map. So that's why, along with Professor Bruce Icklington at the University of Saskatchewan, we design and develop a whole GIS application. It's a software application to identify unconformities from the GIS geological map. So, and it's very important because not many people being able to capture the time gap, the whole age from geological map on the GIS 2D map, and that's what we try to address. And unconformity is so important because it's helped researchers to study and understand Earth history, it's portray the crustal development over Earth history, and it's also associated with mineralizations. The best example will be a world-class uranium unconformity deposit in Athabasca Basin. So that's why we really want to help researchers in the community in general to identify unconformities from GIS geological map.
Okay, awesome. And so what concept does someone need to know to understand your research?
Well, the workflows and the science behind this research is very much straightforward. Again, it's a GIS application, so of course we need the input data sets from a user. So we ask for a polygon shape file, and in this polygon shape file, we need certain attributes for this program to work properly. So first of all, we need rock classifications. Again, very simple, very straightforward. You just have to tell us it's plutonics or sedimentary or volcanics. We need to know the minimum age and the maximum age in million years for each of the record. We need to know the period for, so like Cretaceous, Silurian, Ordovicians, and then we also ask for the unit name. So that is all of the attribute that we ask for polygon shape files. Then the next step is we convert these polygon shape files to lines, and then our GIS applications will have two input shape files. One is polygon, and then the other is lines. So you give the application these two shape files. It's going in, it's gonna calculate the age difference between any two adjacent polygons. If this age difference is a major age difference, then we will classify that as unconformities. Otherwise, we will say, no, it's not unconformity. And the reason why we really need to know the rock classification is to distinguish unconformity from the younger intrusion case, which is you have a sedimentaries or a volcanic rocks and you have plutonic rock going through. That will be the intrusion, not unconformities.
Okay, great. And so what role does data play in your research?
It's very important because, first of all, just like any software application, you give us a big data set, the runtime will be much longer. Furthermore, the result and the qualities of the results will highly depend on the resolution of the age that you give for every single record. So if the age that you record in the app, in your GIS map is not very detailed, then we won't be able to identify any apparent unconformities.
Okay, great. And why is it important for you to share your data and your research?
So the data set is mainly from the user input. So from our research, we don't actually have a data set, but the work is an application, and we want to publish that publicly for everybody to use it because as a researcher, we think it's important to identify unconformities to understand the crustal development over Earth history, and then it strongly supports the mineral exploration and the mining industry.
Thanks for sharing that.
Yeah,
with us
thank you
today.
so much for your time and your consideration. I'm looking forward that everyone gonna use it.
Okay, awesome.
Thanks.
Once again, this is the Data Speaks competition at RFG 2018, created in partnership with Sequent. You can watch the videos on YouTube or Twitter, #CDataSpeak.